Halogen alkanes, when a compound contain a halogen, organic compound such as fluorine, chlorine, bromine or iodine, and we normally use a prefix chloro, fluoro, bromo and iodo. So example, the name of this compound, if we number first, select the longest carbon chain and the numbering should start from nearest functional group or the branch. So 1, 2 and 3. First position we have a bromine, so that's why it is 1 bromo. Because of 3 carbon and N they have a single bond. In this one, this is our longest chain. When we number the carbon 1, 2, 3, 4. So second position we have a carbon chain as a branch and we have chlorine also. So second position it is 2 chloro and 2 methyl. Why we name this chlorine first? It is the when you name these substituent or the branches, it should be alphabetically. So that's why it is 2 chloro 2 methyl butane. Same way, halogen alkane can be classified as primary, secondary or tertiary. As we know, the carbon which is attached with a functional group, if there is only one carbon chain to this, we call that as primary. The carbon which is attached with a functional group, there are two carbon chains attached to it, we call that as secondary. And the carbon which is attached with a functional group, if 3 carbon chains are attached, then we call that as tertiary. So same thing in common name. This is about the common name. A halogen alkane can be classified as primary, secondary or tertiary. IUPAC name is the way we select the longest carbon chain, then we number from the nearest branch or the functional group. Then reactions. The reactions of halogen alkane, their reactions are there are two ways they can react. One is substitution, another one is elimination. If there is a substitution reaction, you have to learn the mechanism of the substitution reaction. Substitution reactions are known as SN reaction. SN means nucleophilic substitution reaction. And these these SN reactions are divided into two classes, SN2 and SN1. A nucleophile means that the substance, the species which is attracted towards the electron deficient side of the positive center of the molecule, we call that as a nucleophile. So what happened in SN2 reaction and what happened in SN1 reaction? Normally in primary compounds, we have SN2, and in tertiary, halogen alkane, we have SN1. What happened in SN2 or SN1 reactions? So if you have a halogen alkane, a halogen alkane can be primary, it can be secondary, it can be tertiary. But if you have a primary halogen alkane, so primary halogen alkane means the carbon chain will be there. The halogen alkane example denoted by N, X here, and because it is a primary, so carbon can form four bonds. One is with the halogen and remaining rest is. This is a carbon example. This is also a carbon chain is there. So this one is a primary. So what happened in primary halogen alkane, and if I draw a tertiary, tertiary means carbon which is attached with a halogen alkane. It can be any halogen alkane. It is having three carbon chains next to this. So if we have a nucleophile, I'm writing nucleophile as Nu, here also Nu. What happened when we compare the electronegativity? Halogens are more electronegative. They have greater tendency to attract the shared pair of electrons. So partial negative on halogen and partial positive on carbon. Same thing, partial negative on halogen, partial positive on carbon. Hydrogen is a small atom, so these nucleophiles are attracted towards, or they can attack on this carbon which is partial positive. So as they can attack on this carbon which is partial positive, that's why we call them as a nucleophile. So two things will happen: bond breaking and bond forming will happen at the same time. Means the carbon, the central carbon, is breaking the bond, it is forming a bond with nucleophile, and it is breaking the bond with halogen. This is the intermediate, and at the last halogen will go out. So as a result, the nucleophile will be attached to this carbon. This is called SN2 reaction. Why we call SN2 reaction? S is for substitution, N is for nucleophile, and 2 here refers to that this reaction depends on the presence of two molecules. One is a nucleophile, another one is halogen alkane. But what about for tertiary? Because carbon alkyl groups are relatively larger in size compared to a single hydrogen. So this nucleophile does not find any space to attack. And if does not find any space to attack, we call that as steric hindrance. So due to steric hindrance, the nucleophile cannot attack on this carbon which is partial positive. So what happened? First, the bond will break. For this reaction to occur, first the bond will break between the halogen alkane and the carbon, so it will form a carbon cation, and then this carbon cation, now there is a space available, so nucleophile can attack now and form a bond. So nucleophile can attack and form a bond with the carbon. We call that as a nucleophilic substitution reaction, but we call SN1. Why we call SN1? Because here this reaction only depends on the presence of one molecule. If this happens, then only the reaction proceed, otherwise the reaction will not proceed. So this is SN1 reaction. Tertiary halogen alkane undergo SN1, primary halogen alkane undergo SN2. And secondary, some secondary can undergo SN1, some can undergo SN2. But for primary it is SN2, and for secondary it is always SN1 reaction. Is it clear? The nucleophilic substitution reactions, SN1 and SN2 reactions. So when we do a reaction, because halogen alkane can undergo two reactions, substitution and elimination. It depends on the conditions, what condition are there. According to the condition they react, that we will discuss. But first thing is the mechanism. You should understand the mechanism. So nucleophilic substitution reaction. Substitution means swapping of the halogen atom by another atom or group of atoms. A nucleophile are electron pair donator. They donate the electron pair or attracted towards the positive center. So if you can see a halogen alkane is there, and this is a primary halogen alkane. So nucleophile having a space, and this reaction is known as SN2 reaction, because the nucleophile and halogen alkane, both molecules are in a rate determining step or responsible for the rate of the reaction or affect the rate of the reaction. So halogen alkane will break the bond. The halogen will break the bond with carbon. So bond breaking and bond forming will take place at the same time. And the rate at which these substitution reaction occur, that depends on the strength of the bond. The weaker the bond, easy to break and faster the reaction. So these are the bond energies, energy required to break these bonds. So if we have carbon and iodine bond, this bond can break easily as compared to carbon and fluorine bond. So that if a halogen alkane contain iodine, it will react faster as compared to when it contain fluorine. So it will slow down. So if this halogen alkane was fluorine, the reaction will occur but at a slower rate. But if we have this iodine, the reaction will occur at a faster rate. So you can see here, this is the nucleophilic substitution reaction. In what condition the substitution reaction occur? It occur in aqueous sodium hydroxide or aqueous hydroxide. When you have a aqueous hydroxide, potassium or sodium, a halogen alkane will convert into alcohol. The equation for this reaction, OH group will take position of Br and it will form KBr plus alcohol will be there. So how we show this reaction, this is very important, the reaction mechanism. So OH, which is a nucleophile attracted towards the partial positive side, the carbon, and bromine will try to break the bond. Bond breaking and bond forming is taking place at the same time. And what is the charge on the transition state? It is negative. Why the charge is negative? Because look, this part of the molecule overall it is neutral. But OH is having an extra electron. So when it is attracted or attached to the molecule, so the net charge on the molecule will be negative, and the bromine will take that extra charge, so bromide ion will be released and it will form a bond with potassium, so result in potassium bromide. This is SN2 reaction. Why 2 reaction? S is for substitution, 2 is for nucleophilic, and why 2? Because the rate of this reaction depends on presence of two molecules. One is the nucleophile, which is OH, and the second one is halogen alkane. But if it was a tertiary halogen alkane, SN1 reaction which occur in a tertiary halogen alkane, you can see this is a tertiary halogen alkane. So nucleophile, which is OH, does not find any space to attack, so it cannot attack and initiate the reaction. The reaction can only be initiated once the bond between carbon and halogen will break, and this will form an intermediate. This intermediate, it will form a carbon cation, and carbon cation attract the nucleophile and it will form an alcohol. So primary halogen alkane do not do SN1 because they have only form an unstable primary carbon cation. Because if there is a, as we discuss in reactions, the carbon cation which is surrounded by more alkyl group is stable. If this was a carbon cation, then this will not be stable. Why it will not be stable? Because only one alkyl group is there. But in tertiary halogen alkane, carbon cation is more stable. This carbon cation is more stable because it is surrounded by more alkyl groups. So tertiary halogen alkane will form a carbon cation, and why it will make, because these methyl groups are known as electron releasing group. So when they are electron releasing group, the net charge on the carbon cation will reduce, so it will make it stable. So SN1 and SN2 reactions are important. Then how we can work out or how we can identify which halogen alkane is there, like whether a halogen alkane is chlorine, bromine or iodine. So when we carry out a reaction, a nucleophilic substitution reaction in aqueous medium, So it will form an alcohol, halogen will be there. And this halogen ion, how we can test? We can add by silver nitrate, or we can add with the lead nitrate. Silver iodide, if it is iodide, if this halogen was iodide, it will give a yellow precipitate. If bromide is there, cream precipitate. And if chloride is there, it will form white precipitate. And for confirmation, we can add aqueous ammonia, dilute. If we add dilute or concentrated, sodium chloride will dissolve. But if we add dilute, sodium bromide will not dissolve, only concentrated it will dissolve. And sodium iodide is insoluble. Which one will form white, the precipitate faster? If halogen contain iodine, it will form precipitate faster. Why? Because the bond between the carbon and iodine is a weak bond, required small amount of energy, so it will break instantly and form an iodide ion. That iodide ion react with silver to form yellow precipitate. So when we break down the molecule by the help of the water, we call that as hydrolysis. So when we carry out hydrolysis in alkaline medium, uh, so it result in a formation of alcohol and the halide ion, which can be precipitate by adding a silver nitrate or lead nitrate. Then nucleophilic reaction with ammonia, the same way. Ammonium ion or ammonia. What is ammonia? Ammonia is NH3, and on nitrogen there's a lone pair. So what happened on that if this is a primary halogen alkane, how it's a primary halogen alkane? Because this contain a one carbon chain attached with a carbon next to halogen. So it will attack bond breaking, and bond forming will take place at the same time. But the carbon cannot form, nitrogen cannot form four bond. This nitrogen cannot form four bonds here. So there will be a positive charge on this. Why there is a positive charge? Because this nitrogen donated a lone pair. So if I draw the structure to show this substitution, any halogen alkane is there. So nitrogen is having a lone pair. It is attracted towards the partial positive side. One of the electron it give to this carbon, to form a bond. Bond breaking and bond forming will take place at the same time. So halogen will be removed because halogen took that electron. So this will be CH3, CH2, carbon, hydrogen, hydrogen, and N. And this nitrogen will have a positive charge. Why positive? Because it donated or give transfer one of the electron. It was having a lone pair. Out in this lone pair, one of the electron is given to a carbon. That's why nitrogen will get a positive charge. But that is not the stable. So when another molecule of ammonia will attract this hydrogen, so nitrogen will take this electron back from hydrogen and it will be neutral. So the resultant molecule will be CH3, CH2, CH2 and NH2. That is called amine. So it will form propyl amine plus NH4 will be there, ammonium ion is there, and that can react it with the ion, halogen ion, which is removed from the beginning, so it will be attached. So ammonium bromide is as formed as a product. So when ammonia is dissolved in ethanol, this is an alcoholic medium. When we heating under pressure in a sealed tube, it should be a sealed tube. So what happened? Ammonia displaces this halogen and form ammonium bromide. And here how we name this is called amine. Amine group means when nitrogen NH2 group is there attached to carbon, we call that amine. So because there are 3 carbons, so it is propyl, it's a branch, and amine group is there, that's why it is amine. So further substitution reaction can occur between halogen alkane and amine, leads to a lower yield of amine, because what happened, this hydrogen can also react with another carbon removed from the other carbon chain, so this will result in a multiple substitution. So if we have a limited amount of ammonia, then it will give multiple substitution. If we have an excess of ammonia, it will reduce the amount of multiple substitution, or it will produce amine itself. Otherwise, the carbon chain will replace this hydrogen and attach. Like if you have ammonia, first carbon chain is removed, hydrogen is removed by carbon chain, then the second, and then the third. This can be minimized by using excess of ammonia to make sure only the first reaction will take place. But if we carry out this same reaction of potassium hydroxide in alcoholic medium, then we call that as elimination reaction. Elimination reaction, it removes the H and halogen group is removed and hydrogen is removed, and the double bond, like example, you have one bromopropane. So if you have one bromopropane, again potassium hydroxide, but this time in alcoholic medium. So H and Br is removed and there will be a double bond between the carbon. Potassium will react with bromine, potassium bromide, and H will OH, it will form water. So in aqueous, there is a substitution, and in alcoholic, there is elimination. When we are adding a potassium hydroxide, so if we have halogen alkane, that halogen alkane will convert into alcohol if we add potassium hydroxide in aqueous medium, and it will convert into alkene if we carry out the reaction in alcoholic medium. First one, aqueous medium is there, it will turn into alcohol, but alcoholic medium, it will turn into alkene. The mechanism you don't have to learn, the important thing you have to learn the mechanism for substitution, SN1 and SN2. So when unsymmetrical or secondary halogen alkane is there, like what happened, there are two possibilities. What are the possibilities which can form? If this chlorine is removed and hydrogen is removed, then it will form 2-methyl butanene. But second thing, what can happen, this chlorine is removed and the other hydrogen is removed, so it can form 2-methyl butane. So both possibilities are there. The structure of halogen also affects the degree of which substitution or elimination can occur. Primary tend towards the substitution, tertiary tend towards elimination. Then the uses of the halogen alkane: used as a refrigerant, fire retardant, and aerosol propellant. What is the reason why we use them? Because they can absorb greater amount of energy before converting back into gaseous state. They are inert, so we can use as a fire retardant. And chloroalkenes or chlorofluoroalkenes can be used as a solvent as well. But many of these uses are not, many of these compounds CFCs are not used because they are toxic and cause an ozone depletion. Is it clear? So today we discuss alcohols and halogen alkanes. Any doubt related to the class? Any question or a doubt? After completing the topics, we will do topic-wise questions, like we completed halogen alkane and alcohols and halogen alkanes. So next session we'll discuss the questions related to this topic.